For number 8, if 36.5 meters cubed, so that's a volume, of a gas collected at a pressure and temperature of 755 millimeters of mercury, so that is a pressure, and 280 kelvins, that's a temperature, what volume will the gas occupy if the pressure and temperature change to 632 millimeters mercury, so that's also a pressure, and 305 kelvins, it's also a temperature. So first I'm just going to sort out all of my numbers. So my volume 1 is equal to 36.5. My initial pressure is 755. My initial temperature is 280. We're asked what volume, so I don't know my final volume. My final pressure is 632. And my final temperature is 305. So I'm going to rewrite my equation here. I'm going to exclude all variables that are constant. Here there's no mention of number of particles, so that is constant. So P1 V1 divided by T1 is equal to P2 V2 divided by T2. So again, I'm just going to cross multiply this. So T1 P2 V2 is equal to P1 V1 T2. Now I can plug things in. T1 is 280, P2 is 632, V2 is I don't know, P1 is 755, V1 is 36.5, and T2 is 305. So I'm going to simplify the left side of the equation first. So 280 times 632, and we end up getting 176,960. And we can set that equal, there's still a V2 there. And that's equal to 755 times 36.5 times 305. And we end up getting this very large number. Just going to double check that since it's so big. Times 36.5 times 305. I think that was a different number again. Okay. Anytime you get like a really weird number in your calculator, it's always a good idea to just double check it. So 8405037.5. When I'm rewriting these big numbers, I don't ever put in the commas just because I don't want to mix up the comma and the decimal point. Okay, so now we can isolate V2 by dividing each side by 176,960. So dividing each side by 176,960. So divided by 176,960. We end up getting 47.496. That's going to end up rounding to, V2 is equal to 47.50, and my volume unit was meters cubed.